Hi, the current title of my project is Optimising the Concentrated Discharge from Desalination Plants. Desalination plants and the process behind the different desalination technologies is a very broad aspect, so I guess the important thing I've begun to do is refine the scope for my project and understand what I want to deliver by the end of the project through my research and testing in the future. In this presentation, I will quickly cover some background info. Then I will briefly talk about some desalination technologies and systems, which will then lead into the major components of my project so far, which are the methods of brine usage currently in place, the different storage facilities, the extraction methods, the risks with concentrated discharge and storage, as well as some initial ideas on how to optimize the storage and the use of this concentrate. Okay, so the idea for this project was given to me by Rio Tinto, who are interested in using the desalination technology to produce water for the purpose of beneficiation plants. There are several industries in Australia which have chosen to use desalination technology for different purposes. Some examples are for drinking water, for irrigation water, and for the treatment of water extracted from coal seams in the coal seam gas industry. Overall, the two major uses for desalination technology are for source of fresh water and as a tool to manage water salinity levels. The desalination process is a simple concept which separates the salt minerals from the saline solution. Reverse osmosis membrane technology seems to be the common type of desalination technology which is used in Australia. No matter which desalination method is used, however, there is still the issue of the leftover concentrated brine, which is the byproduct of the desalination process. A report by URS titled Economic and Technical Assessment of Desalination Technologies in Australia discusses factors influencing technology selection and also opportunistic production and offset benefits such as the concentrate disposal. And this report I found extremely useful in understanding the logic behind selecting different desalination technology and the systems in place for different Australian regions, specifically the difference between coastal plants and more remote inland plants. For my initial research, I classed the desalination plants into these two different categories based on the locations. The inland, more remote places, such as those in the Surat and Bowen basins, where there is no real viable way of discharging concentrated brine into the ocean. And also the other type of plants which are located near the sea, which are able to do so. I've researched a bit of both, however, and I believe the large issues lie with the inland areas, such as those in the coal seam gas industry, due to the options available for disposing of the brine in remote areas. The major differences between these two categories is the way in which the concentrated brine is treated and dealt with, and each results in different environmental and economic effects. For desalination plants located in coastal or estuarine areas, the obvious method for brine disposal which is conventionally used is to discharge back into the ocean, which is usually where the water intake source is from in the first place. There are various published reports which do investigate the environmental effects of mixing this concentrated brine back into the ocean, which varies in concentration of 30 to 70% times the concentration of the original intake solution. The higher concentration results in the discharge sinking down to the bottom of the seabed once released, and this has some adverse effects on flora and fauna. Further research is obviously needed to understand these effects further. As a result, it has been mentioned in various studies that the location of discharge points into the ocean is critical in limiting the environmental interactions. For desalination plants located at inland areas, the methods of disposal of the concentrate is more limited depending on the surrounding environment and the available land space. Some options include evaporation ponds, deep well aquifer re-injection, watercourse or natural wetland discharge, as well as possible beneficial reuse for commercial and industrial use. A lot of these are deemed non-feasible due to the costs involved though. A large issue with each of these options is the immediate and long-term environmental impacts, as well as the long-term build-up and economic costs to store and remove stored concentrates. Evaporation ponds are a common method of brine disposal / storage of the concentrate and are used throughout parts of the Surat Basin in the coal seam gas industry. However, the problems associated with this occur when the salt precipitation and build-up exceeds the capacity of these storage areas, meaning that there is the potential for uncontrolled interactions with the environment. Costs of wall raises and reseals of the storage areas are very unsustainable in the long term, and there has been growing interest from a number of parties such as Arrow Energy, Origin Energy, for alternative measures to be adopted. Obviously, with flooding as well, with these evaporation ponds can cause some interactions, some unwanted interactions between the concentrate and the environment. From my research so far, some methods which I believe are feasible include salt encapsulation technology, which can refine the mineral to a form which can then be used for other purposes. An extremely important factor in this, however, is investigating at which point is optimal to extract brine from the storage facilities if they are used, at which point they can be stored or disposed of elsewhere or converted to a refined crystallized form using mechanical crystallization systems. This means I need to continue researching the storage facilities and different stages of the salt crystallization and precipitation process and the effects of increasing concentration as water extraction continues from these coal seams. This is a summary of the key aspects of my project as I currently see it. Further research needs to be done to increase my understanding of the processes and which potential solutions can further be investigated and tested. Thanks.